Hello pre-calculus kids, welcome to the last section that we're going to be covering for the year. This is section 12.3 and it's on area of triangles. You already know, and I know you know from geometry, that the area of a triangle is 1/2 the base times the height. But what happens if you've got something like these triangles where you don't really know? Well, this one you do know what the base is, but you'd have to figure out what that height is. That would take you a little bit of work because you'd have to use your law of sines and cosines to figure out the angles. Or you'd have some situation like this, and again you'd have to figure out the base and the height to be able to figure out the area of that triangle. So lucky for us, there are two formulas that mathematicians have come up with when you have triangles like these, where it's not quite so easy to figure out what the base is and what the height is to do the traditional area formula. So here's what it is. Let me show you what they look like. There are two situations where these formulas work. This is just the back of your mastery sheet that I'm going to put this. And they must be when you're given, do you remember this from back in geometry? Side, 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 or side, angle, side. If they give you these two situations in a triangle, then it's easiest to use these new formulas I'm going to show you to be able to figure out the what the area is. So I'm going to start with a side, angle, side because it's a little bit simpler. So if I have a side, angle, side situation back from geometry, it would look like this. Here's your triangle. I'm just going to make up numbers and show you how it works. Say I know that this side is 5 and this side is 8, and the angle between them is 100. That's a side, angle, side situation. You've got two sides and the included angle. That's how it would have been discussed back in the days of geometry. And there's a really easy formula, and it says this, that the area is 1/2 whatever the sides are, 5 times 8, and then times the sine of the included angle. That's it. That's the area of the formula. And you can see that's way easier than if I had to divide this down, figure out what the height is, and then calculate what the base is, and then use the traditional area equals 1/2 the base times the height. So let's see what this comes out to be. If I go to my handy dandy calculator, I want to make sure that I am in degrees, and I am. And so I'm going to put in my formula, quit out of that. It is going to be 1/2 of 5 times 8. I'll use 0.5. 0.5 times 5 times 8 times the sine of 100 degrees. And putting all that in my calculator gives me out an answer of 19.7. So my area for this triangle is 19.7, and then it's whatever the units are squared. Now they didn't tell me units in this, but some of our questions will have that. Remember, any area is going to be the units squared. So there's a side, angle, side situation. Here's your formula. Take the two sides, take half of them, and the sine of the included angle. And that just tells you what the area is. Really cool. If you have a side, side, side situation, it's a little bit different. The formula is a little bit different. This one's called Heron's formula, is most times how I've seen it. The people on Flip Math, they call it Hero's formula, and you'll see that when you watch that video. But here's a situation in a side, side, side. And again, I'm going to just make up numbers. So they give you one side is 5, say one side is 7, and one side is 10. And again, if I were to use the 1/2 the base times the height, this time I have the base, but I'd still need to figure out what that height is. And so in this case, there's a formula, Heron's formula, and it starts with something called a semi-perimeter. Now, semi means half. So what you want to find is this S value, and it's half of whatever the perimeter is. So let's see what that's going to be for our formula here, for our particular triangle. It'll be 1/2 of perimeter is just add up the sides. So 1/2 of 5 plus 7 plus 10, that's half of 22, gives me an 11. So I get an S value that's 11. And here's how this area formula goes. You need a little bit more space for this one. Big square root. It goes S, 11. And then it's going to be S minus the first side, 5, times S minus the second side, times S minus the third side, and then you take the square root of that whole hot mess. And so it's really just a matter of putting all of that into your calculator. So if I make it a little simpler on myself, it's 11 times 6 times 4 times 1. And I want to take the square root of that. Well, if I take all those numbers and I multiply them together, you can check me out, I get the square root of 264. If I take the square root of that, my area is 16.2. And again, I don't have units necessarily for this particular problem, so I'm just going to say units squared because it is an area. And that's how the area formulas work for this particular section. You either have a side angle side situation using this, or you have a side 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 situation using this semi-perimeter and big old square root thing. All right, so let's try the few problems that are here on your mastery check that we're going to do as an intro. You can see that I have a side angle side situation for this first one. So that's going to be the area equals 1/2 the two sides multiplied together times the sine of the included angle. It's just that simple. And so when I put that together, my area, you can put in your calculator, comes out to be 7. And so then it's just whatever the units are, meters in this case squared. There it is, done. Number 2 gives you the second scenario with the side, side, side situation. So this one I have to figure out what S is, the semi-perimeter, which is half of the perimeter of the triangle, 6 plus 7 plus 12. So I get an S value this time. It doesn't come out even, but that's okay, 12.5. And then you're going to put the area formula together for this one with that big, humongous square root. Start with the S, 12.5, and then take the S and subtract away each side for 3 sets of parentheses here. So 12.5 minus 6, 12.5 minus 7, 12.5 minus 12. You can put that whole thing in your calculator. I tend to like to just do what those parentheses are just because, but you can do it however you want. 12.5 times 6.5 times 5.5 times 0.5. So I put all those things in my lovely calculator and I subtract away, I multiply it out, and then I take the square root. I get an area of square root of 223.44, and square root of that is 14.9. I have units, they're feet. That'll be feet squared. So there's the area for that triangle. And again, this is a lot simpler than trying to figure out what that height is and using the old traditional area is 1/2 the base times the height. Now, there could be some situations where you get something that's slightly more complicated, but now that you know the law of sines and law of cosines, it's going to make the problem a bazillion times easier. So we're going to start with drawing our triangle. Here's my R, here's my S, here's my T. I know that little t is 11, opposite. Little s is 5. And angle T is 56. And so you say to yourself, is that a side angle side situation? Remember, these formulas only work if it's side angle side or side side side. And in this case, it is not, because your two sides are here. The included angle would be R. You don't have that. You have T, and you have no information to be able to use your fact that you know a triangle adds up to 180 degrees to get the other angles. So we're going to go for finding angle R. Now we have choices. We know the law of sines and we know the law of cosines, and you can use whatever one you want to be able to figure this out, but I guess it's probably easiest. Let's just use, see, I know two things about T. Let's use the law of sines. So the sine of 56, big T, over 11, little t. I want to know R equals the sine of R over, oh, can I even do that? I can't use R, can I? I don't know what its opposite side is, so I've got to find S. All right, well, let me erase this part out. All right, sine of S, because I know what little s is. Otherwise, I would have had too many unknowns in my proportion. So here's a 5. All right, so I go to the calculator and I say, all right, calculator, what is the sine of 56? And it says 0.829. I say, okay. So I have 0.829 over 11 equals the sine of s over 5. And so you're going to cross multiply 0.829 times 5 divided by 11. That gives you the sine of s is a decimal point of 0.377. So you do sine to the -1. You want to know the angle, 0.377. And out pops your reference angle of 22.15. Now remember law of sines. Sine is positive in the first quadrant and in the second quadrant. This would be 22.15 in the first. In the second, it will be 180 minus that. And that gives you a value of 157.85. But that would be too big because 157 plus 56 is over 200. So you know that angle S has to be 22.15. Well, if angle S is 22.15, you can figure out angle R because you know the triangle has to add up to be 180 degrees. So if you take 180, subtract 56, subtract 22.15, you get 101.85 degrees. So that's your angle here, 101.85. Now you can use your formula because now you have a side angle side situation. So your area is 1/2 of the two sides, 5 and 11, and the sine of the included angle of 101.85. And so it's just a matter of tossing all of that into your calculator and it'll calculate out what your value is. You get 26.9. Your units are centimeters, so centimeters squared, and there's the area. So the whole section 12.3 is all about finding the area of triangles. Sometimes they're straightforward and nice and easy peasy. This is a side angle side situation, you got it. This one was a side, a little more work, but not too hard. And then sometimes you're going to have to dig a little bit to be able to get what that missing angle or side is so that you can apply the formula. All right, that is section 12.3. The next time I see you, it will be for some example problems, some up from the practice section. And as always, hope you're doing well, and email me if you've got any questions. See ya.